Diagram shows a curve where M is a maximum point where X is A. We need to show that A satisfies the equation that A is tangent of 2A over 1 plus A squared. This value of A is the X value where M is the maximum. So at this value of A, the derivative dy dx must be 0. In this case, we have to find dy dx first. And since y is arctangent of x over square root of x, we need to apply the quotient rule. So we have square root of x, and we differentiate arctangent of x. When we differentiate arctangent of x, we have 1 over 1 plus x squared, and this will give us 1 over 1 plus x squared minus arctangent of x, and the derivative of the square root of x is 1 over 2 root x. This is all over the square of the denominator, so we square the square root of x, which is x. We can write this as square root of x over 1 plus x squared minus arctangent of x over 2 root x all over x. X equals A when dy dx is 0. So for this case, we set dy dx to 0. When this is set to 0, we can multiply throughout by x, that x is gone. So dy dx is 0 only when the numerator is 0. So for this case, this implies that square root of x over 1 plus x squared equals, minus arctangent of x over 2 root x equals 0. We can rearrange so that arctangent of x over 2 root x equals square root of x over 1 plus x squared. And we multiply throughout by 2 root x. That will give us arctangent x equals 2x. Root x times root x will give us x over 1 plus x squared. Arctangent of x. So from here, we have x equals tangent of 2x over 1 plus x squared. And this x equals A at this maximum point. So we let x to be A, and we have A equals tangent to A over 1 plus A squared. That is part A. Part B, we need to verify by calculation that A is in between 1.3 and 1.5. We can rearrange A equals tangent of 2A over 1 plus A squared, and we can write f at A equals A minus tangent of 2A over 1 plus A squared. And we need to show that f of A is, there is a 0 between 1.3 and 1.5, meaning that one of these values will give you an f of A value that is negative, the other one must be positive. So we find f at 1.3, we have 1.3 minus tangent of 2 times 1.3 over 1 plus 1.3 squared. And when we evaluate this, you make sure that your calculator is in radian mode and not degree mode. These are not these are in radian. This will give us a value of negative 0.148. And we find f at A when A is 1.5. We have 1.5 minus tangent of 2 times 1.5 over 1 plus 1.5 squared. And this has a value of 0.178. We see that f at 1.3 is negative, so there must be a value of a such that f of a is 0. Then this is f of 1.5. Then a must be in between 1.3 and 1.5. Part C, we need to use an iterative formula based on the equation in part A to determine A correct to 2 decimal places. To do that, part C here, we can let A sub n plus 1 to be tangent of 2 A sub n over 1 plus A sub n squared. And we know that A is in between 1.3 and 1.5. So to get a faster convergence, we can always let A naught to be 1.4. Well, this is right smack in the middle of 1.3 and 1.5. So this will ensure that we have a faster convergence. A sub n is, A sub 1 now becomes tangent of 2 times 1.4 over 1 plus 1.4 squared. That gives us 1.3865. Then we can compute A sub 2 based on A sub 1. We have 1.3865 all over 1 plus 1.3865 squared. And that has a value of 1.3951. But this doesn't converge yet. So A sub 3, we continue on. We have 1.3951 and then 1.3951 squared. And we get 1.3896. To find the next one, we have 2 times 1.3896 over 1 plus 1.3896 squared. And this gives us a value of 1.3931. A sub 5 is tangent of 2, 1.3931 over 1 plus 1.3931 squared. This is 1.3909. So this to 2 decimal is 1.39. This is also 1.39 to 2 decimal and 1.39 to 2 decimals. Since 3 of them are the same, we say that A is 1.39.